Hello. In this video, we're going to take a look at a different type of function. We've been looking so far at sketching radical functions, and now I want us to look at sketching rational functions. So a rational function is a function that is a fraction. A rational means fraction. And so we're going to start with the easiest one, 1 over x. And let's go ahead and sketch the graph. This was hopefully done for you last year. And if you want, we can make a quick table of values here. So we'll go like this, x and y, negative 3, negative 2, negative 1, 0, 1, 2, and 3. Now we do the reciprocal. So the reciprocal of negative 3 is negative a third, negative a half, negative 1. Well, we can't reciprocal 0 because it would be 1 over 0, which is undefined. Can't divide by 0. Reciprocal of 1 is 1, 1 half, and 1 third. So because of this right here, we end up with what's known as an asymptote. So right here, we draw this dotted line because we're not allowed to divide by 0. And then we put the other points. So we have a point at 1 and 1. We have a point at 2 and a half, 3 and a third. And then the same thing over here, negative 1 and 1, negative 2 and a half, negative 3 and a third. Now for these graphs, there's also a horizontal asymptote. There's also a horizontal asymptote at y equals 0. And we'll talk more about this as we go through the series of videos. But for right now, we'll just put that asymptote at y equals 0. It's just sort of a given. And now we use these asymptotes as guidelines to sketch our graph. So as we go up this way, we approach the asymptote. As we go down this way, we approach the asymptote. And then we approach and approach this way. And there we have our graph of 1 over x. Sometimes I like to call these a swoosh. It looks sort of like you took the asymptotes as your guideline, you kind of just did a swoosh. And so we have a swoosh over here, and we also have another swoosh over here. And that's our graph of 1 over x. Now what if we did 1 over x minus 2 plus 3? Well, I mean, this is sort of like the other graph, but we've done a couple things to it. We have a minus 2 here, we have a plus 3 here. It's almost like we could consider this a transformation of the underlying graph. Because if we think about it, the plus 3 here would mean a vertical translation, 3 up, 3 units up, and this negative 2 down here would be a horizontal translation of 2 units to the right. Now, we could grab the original points and then do these transformations to them, but I think it's a little tricky to memorize all those points, especially with the fractions. So what I'm going to do is I'm just going to imagine translating the asymptotes. And from there, I'm just going to then grab some points. So if we do a horizontal translation of 2 to the right, that means the asymptote is going to move over 2 to the right. The vertical asymptote that was at x equals 0 is now going to be at x equals 2. That's our vertical asymptote. And it kind of makes sense because you could imagine trying to plug in x equals 2 into the function and you'd be like, oh, that's not going to work. 2 minus 2 is 0 and we can't divide by 0. Similarly, we're going to take that horizontal asymptote and we'll move it up to 3. So there's my horizontal asymptote at y equals 3. Now from here, we can just go ahead and pick a couple points. So let's pick x equals 3. X equals 3. Y equals 1 over 3 minus 2 plus 3. So 1 over 1 plus 3, so 4. So here's going to be 1 point at 3 and 4. And because we know it's going to be a swoosh graph, we actually only need 1 point to determine how the swoosh looks. We take this 1 point, we approach the asymptote up top, approach the asymptote underneath, and we're golden. Now let's pick another point, maybe on the left. Let's do x equals 1. So over here we'll do x equals 1, y equals 1 over 1 minus 2 plus 3. So that's 1 over negative 1 plus 3, so negative 1 plus 3, which is 2. Okay, there's our other point. And again, we use those asymptotes as guidelines, and we simply draw our swoosh, and we're good to go. All right, so go ahead and pause the video and give this one a try. Again, I would recommend you move those vertical and horizontal asymptotes, then just plug in a couple points, one on either side or in each section, and you should have the graph of the function. So assuming you gave this a try, we should have here, based on this, 1, 2, 3, 4, 5. So there's my vertical asymptote at x equals 5. And based on this, we're going to move down 1. So there is my horizontal asymptote at y equals 1. Now I'll make a little table of values. I'll do 1 point on the left of the vertical asymptote, so 4, and I'll do 1 point on the right, so 6. When you plug in 6, 6 minus 5, so 2 over 6 minus 5 minus 1. So that's 2 over 1 minus 1, so that'll give you 1 right here. When I plug in 4, 2 over 4 minus 5 minus 1, that'll be negative 3. And then again, I just draw my swooshes. Now, if you look, this graph is a little bit stretched. You could imagine that the 2 up here is a vertical stretch by a factor of 2. But again, because we're not necessarily using the base graph precisely, we don't necessarily need to account for it like a mapping. We're not over here saying, okay, here's our initial table with all of our points, and then mapping it to the new table. We're not really doing that method. We're more just taking the original 2 asymptotes, mapping them to the new asymptotes, and then grabbing a couple points. And the reason that vertical stretch doesn't affect the asymptotes is, well, the asymptotes are already at 0, 0. So when you go to do the multiplication by 2, it doesn't change anything. It's only the translations that affect the asymptotes, not the stretches. All right, go ahead and give this one a try. Okay, so assuming you give that a try here, again, that bottom is going to give us x equals negative 3 as our vertical asymptote. And because there's nothing on the horizontal, there's nothing, it's like a plus 0, like nothing's happening out here, we can just go ahead and keep it where it normally is. Horizontal asymptote at y equals 0. Then we go ahead and do a little table. So let's pick a point, 1 on the left here. So that'll be at negative 4. And then we'll pick a point on the right, so negative 2. At negative 4, we have negative 1 over, that'll be negative 1. So that'll actually give us 1. Okay, that's interesting. And then negative 1 over 1 will be negative 1. So negative 4, we have negative 1. Oh, sorry, at negative 4, we have positive 1. And at negative 2, we have negative 1. So that actually creates a bit of a strange shape. It still swooshes. Still use those asymptotes as our guidelines. But this time, if you notice, the swooshes are in the opposite corners. Normally, it was like this, right? Normally, it was swoosh, swoosh. Now, we have swoosh, swoosh. And that kind of makes sense because this negative 1 is going to be a vertical reflection. Now again, the vertical reflection doesn't change the asymptotes, but it does change the graph, and it moves the graph to the opposite sides. It reflects it, right? The swoosh that was up here has been reflected down to here, and the swoosh that used to be down here has been reflected up to here. All right, now here's a real challenging one. We have 3x minus 2 over x minus 1. And because there's some stuff on the top, I don't think we can identify the asymptotes as cleanly. So what I would encourage you to do is use a little bit of division. maybe a little bit of long division, synthetic division, to get it into its standard form where we just have like a 1 or a -1 on top. And then I think we'll be able to determine the asymptotes. All right, so assuming you did synthetic, we have 3, -2. And on the bottom, we're plugging in x equals 1. So we get 3. 3 times 1 is 3. This will be 1. So that means we could write it as, here's our remainder. Here's our quotient. And so if you remember, we can write it as 3x minus 2 over x minus 1 equals quotient plus remainder over divisor. So quotient plus remainder over divisor. And if we write it in our more typical term, it's 1 over x minus 1 plus 3. There we go. This is sometimes called standard form. Standard form. So now we can identify, okay. This here remained the same. This is our vertical asymptote at x equals 1. And here is our horizontal asymptote. Let me just put that over here. Horizontal asymptote at y equals plus 3. So we go up 3. And we go over 1. And then we pick some values. We can plug them back into the original one, the standard form. It doesn't really matter. We're going to pick 1 on the left, so we'll do 0, and 1 on the right, we'll do 2. When you plug in 0, you should get -1 plus 3, so 2. When you plug in 2, that will give us 1 over 1 plus 3, so 4. 0, 2, and 2 and 4. Draw some swooshes, and we're good to go. All right, so we'll do one more like that. Again, pause the video, do some synthetic, get it in standard form, then go ahead and graph it based on those asymptotes. All right, so assuming you did your synthetic division correctly, you should have the following. So it's going to be -3. -3 times 4 is -12, so this will give us -4. So we can write it as quotient plus remainder over divisor. And it's nice to flip it around. So -4 over x plus 3 plus 4. That means here we have x equals -3. Vertical asymptote, y equals 4, horizontal asymptote, all right, and we need a little table here, so we'll plug in -4 and we'll plug in -2. So when we plug in -4, we're going to get -4 over -1 plus 4. So that's going to be 4 plus 4. That'll be 8. Okay, that'll be up here. And then when we plug in -2, we have -4 over, that'll be 1 plus 4, so it'd be 0. Okay, right there. Now we go ahead and sketch the graph. Now in this case, if you notice, it does go through the y-axis, so it might be nice to figure out exactly where that point is, right? That's the y-intercept. And maybe they're asking for that on the graph, right? Maybe they want to know the y-intercept. I mean, we have the x-intercept right here. We have an x-intercept at x equals -2. So that's kind of cool. But let's try to find the y-intercept. So to find the y-intercept, we set x equal to 0. And again, we could do that in the original question. We could do that in the simplified version. I'm actually going to do it in the original one up here. So I'm going to get 8 over 3 because the x's just go away. So the y-intercept is at y equals 8 over 3. So technically, this point right here would be at 8 over 3. Okay, and maybe one other thing we could extend off of this, maybe we could write the domain in range. That might be interesting to do. Let me just make a little space down here. So let's put the domain. The domain looks like we include every value except for -3. The way we write that is negative infinity to -3, union -3 to infinity. And for the range, it looks like we include every value except for 4, because it never hits that blue line. So it would be negative infinity to 4, union 4 to infinity. We put round brackets around the infinity because it's not a number, it's just like a concept. And we put round brackets around the -3 and the 4 because we don't actually attain those values. All right, let's go ahead and take some notes on this. So this is graphing basic rational functions. And the best thing to do is to find the asymptotes, find the vertical asymptote, and that'll be the NPV for x. Find the horizontal asymptote, that'll be y equals 0, and then apply any vertical translation. And then pick a point on either side. Now, of course, we have to remember sometimes it's nice to put in standard form with synthetic division. And so right away, we might want to write down a thing to remember here. So in case you forget, it's nice to remember that if you're doing p of x over d of x, it's equal to the quotient plus the remainder over the divisor. So that's the form when you do the synthetic. You put the quotient there, then the remainder over the divisor. Okay, popping back to our example though, let's see if you can go ahead and sketch this. We have y equals -1 over x minus 2 plus 7. I've already put it in standard form for you, so you just need to find the asymptotes, pick some points, and give it a sketch. All right, so assuming you did that, here we have 1, 2, because of this. There's our vertical asymptote. Here we have 1, 2, 3, 4, 5, 6, 7. Maybe we need to extend this just a little bit. Pick a point at 3 and at 1. When you plug in 3, you should get 6. When you plug in 1, you should get 8. And so we end up with a graph like this. Kind of running into my question over here. It's a little tricky. There we go. Now for your extra practice, I would look at worksheet 6 and 6.5. Definitely could add one of those questions here to complete your notes. And then other things to remember too, it's important that the asymptotes are guides. We'll talk more about asymptotes in future lessons, but the asymptotes really help give you that shape. They help guide your function, and so you really want to use them to your advantage. They allow you to need a lot less points because we know it's going to be a swoosh. We know those asymptotes guide our swoosh, and now we just need to figure out whether the swoosh is in the top or the bottom, and that's what that point does for us. All right, hopefully you enjoyed this video, and as always, thanks for watching.